Hello, everyone. My name's Wayne Honeycutt, and I have the pleasure of serving as the CEO for the Soil Health Institute. I'm a soil scientist by training. I used to conduct research for some 25 years in carbon, nitrogen, and phosphorus cycling and on-farm cropping systems. And so it's a real pleasure to visit with you today on some real practical approaches for looking at how we best manage for increasing soil carbon. So what I'd like to do today is just kind of step you through about 4 different areas. What is soil organic carbon? How does it benefit farming? How can you as a farmer increase it? And basically, how long does it take? And what are some of the factors that influence how long it takes? So let's jump right in. So I'm sure everybody here realizes that, soil organic matter is really what imparts that dark color to soils. Soil organic matter itself is made of carbon, but also has things like nitrogen, phosphorus, other things in it. And it's really formed from the decomposition of things like plant material, animal material. And it really gets to a point where those leaves and stems and roots that initiated that development of that organic matter really becomes a kind of part of the soil. So you can no longer distinguish the roots and the stems and the leaves in it anymore. It actually becomes part of that soil organic matter. But as I say, soil organic matter has more in it than just carbon. It has things like nitrogen and phosphorus and other elements in it. So that really all we're really talking about here is that fraction of the organic matter that is carbon. So that's what soil organic carbon is. It's the carbon in soil organic matter. So how does soil organic carbon benefit farming? This little dark layer here of soil, right underneath this crop, right underneath this gentleman's feet, this dark enriched organic carbon, organic matter, how does it really benefit farming? There's a number of ways that it benefits. For one example, is organic carbon increases water holding capacity in soils. So this is shown on this graph that we just recently developed here at the Soil Health Institute, looking at available water holding capacity on this y-axis here, and then also clay content on the x-axis, because we found that clay content also influences it. But look what happens when we increase the organic carbon from 1% to 2%, 3%, 4%. What happens now to available water holding capacity? Just take any one of these levels here. Let's say we have 20% clay. Now we're at available water holding capacity of about 18% of that soil can hold plant available water. But when you increase from 1% carbon to 2% organic carbon, now over 20% of that soil can hold plant available water. Same, you can keep seeing the increases, you increase organic carbon. So this is a really important point because it really benefits drought resilience. Now, organic carbon also affects density. Look what happens here when you increase carbon. We've got over 1,000 data points in this one particular study here, that when you increase carbon, what happens to density? The density decreases as you go. Now think of what that means to a plant root. Now, with the soil being less dense, now roots can now travel through that soil easier. They can scavenge for nutrients and water easier and make basically, a healthier plant. Now, another factor of carbon is in what we call aggregation. Carbon is really key for forming soil aggregates. And what we're talking about here is where the individual sand, silt, and clay particles, they bind together in what we call aggregates. Now you can kind of focus in here, this little spot of soil on the left that's labeled no-till, and you can see these kind of little clumps, little granules, meaning about the size of a pencil head, eraser. And so this no-till really helps preserve, a lot of those aggregates. And also, of course, it increases carbon, the no-till does. That allows more of those aggregates to form, but then it also protects it. So what's happened here is these folks have gone out at Purdue, they've gone out in the field on a farmer's field and taken some soil from a no-till field and a soil from a tilled field, and they put it in little sieves, soak it in water, then they flop them upside down and see, what remains. You can see the aggregates are still very much visible in the no-till, but they're not in the field that was tilled. Now, this is just doesn't happen on an experimental basis. It happens in real life too. So you can see the field on the left, they're using they're using the soil health building practices of no tillage, where there's a lot of residue on the surface. That residue decomposes, it adds more carbon to the soil, that helps more aggregates formed, and then that residue also protects those aggregates. So when the raindrops come, they don't break them down as easily. Here, the field on the right that does not have that protection, likely has less carbon because they're not using the soil health promoting practice here. And so now the water's ponded. And so this field on the right is really kind of losing some of that opportunity for recharging that soil with moisture. So it will have less available to it likely during that next dry spell when it comes along. So how does soil organic carbon really benefit farming? Well, we've already just talked about 3 of them. Increases available water holding capacity, reduces the density, increases water infiltration. But there's many, many other benefits too. I don't have time to go through all of them, but I'll just do it in writing here instead of with pictures and graphs. But one of them is that it really increases nutrient availability. You may recall that I said that organic matter doesn't have just carbon, but it has things like nitrogen and phosphorus. So when the microbial organisms, when they start to feed on that carbon, well, then it will release nitrogen and phosphorus, so make more nutrients available to the plant. And so you can build up enough nutrients in the soil, and to a certain extent that now you can start measuring that and being able to check back on some of your fertilizer applications. Improves trafficability, increases yield stability, and increases profitability. The yield stability, we think that there definitely needs to be more research done on that. A lot of the numbers are just not available for us as scientists to look at, but so many farmers that we speak to have told us when they have adopted these soil practices that increase carbon in their soils, it also really helps with their yield stability. And they can see it particularly during the dry year compared to their neighbors that are not using these soil health or soil carbon building practices. We are also learning. We just recently interviewed 125 farmers on their profitability of using these soil health systems that build carbon. Almost all of them, well over 95% of them have reported increased profitability from using these systems. And then, of course, then there's opportunities that some farmers have of these environmental markets like carbon markets that also can be another source of revenue for increasing profitability using these soil health promoting practices, these soil carbon benefiting practices. So how can you increase soil organic carbon on your farm? To do that, I think it's really important to just kind of take a step back and think about kind of a real fundamental level of the carbon cycle. Now, I'm not going to get into the kind of the transportation part of the cycle or the manufacturing part of the cycle. We just really kind of focusing in on some components of it that are really kind of important to you, as a farmer. Now, we know that photosynthesis, it's a way that plants, they convert light energy, and they use that light energy, I should say, and then they take carbon dioxide and water, and they essentially convert those into sugars that their plants can use for their growth. So this word photosynthesis, you kind of break it down, photo meaning light, of course, synthesis to synthesize or produce something. So it's that light energy from the sun that the plant is using to synthesize those sugars. And it does that by, again, bringing in the carbon dioxide into the plant and also taking water and then combining those to form sugars. So some of those sugars transferred down in the plant into the roots develop, they decompose the plants, microbial, I shouldn't say plants, but the microbial organisms in the soil, they help decompose the plant material, things like the leaves that fall off, The microbes help decompose some of the roots. Some of the materials come out of the roots called root exudates that are very rich and help feed the microbes. So when all that happens now, some of the microbes, they respire carbon dioxide back to the air. And so you can see that we have carbon dioxide coming in, making its way to the soil. But we also have carbon dioxide going back up to the atmosphere. So really what's important here is it's all about balance. It's about balancing your inputs of carbon with the amount of carbon that is removed, like from the harvest of the plant, or carbon that's removed back to the atmosphere, like through the respiration. So this kind of depicts what that balance is. Is that our goal is to really to store more carbon in the soil than to lose back to the atmosphere or that's removed from harvest. Now, how do we do that? How do we affect what really goes back to the air, the atmosphere? Well, it's largely through tillage. When we use no-till, then we are keeping more of that carbon in the soil. When we till, now we're releasing a lot of it, and we're letting those microbes attack more of that carbon in there that now becomes carbon dioxide back to the air. Harvest. We all, of course, you gotta have a harvest, but it's now what you do with those residues. And it depends on, how you manage that crop. If, for example, you can imagine that if you're harvesting your corn for grain, you're really adding a lot of residue, a lot of carbon back to that soil. But if you're also harvesting your crop as silage, well, then you can imagine that now you're removing it all. And so you're not adding much carbon back to that soil. And so there, all these different management decisions really kind of play into affecting that balance. And your charge really is to, sorry to say, but it's not just to think of yourself as a farmer or like a soybean and corn farmer, but also to think of yourself, please, as a carbon manager, because that's the way that you're going to be able to increase carbon in your soil and increase the health of that soil and provide a lot of these benefits to you, your farm, and your family. So I've already given you the answer. How do you increase carbon in your soils? It's through management. It's through those management decisions that you make when you're selecting how you're going to do things on the farm. So an example is no-till. And we've already talked about it a little bit, but it's very clear that when you have a no-tillage situation, you have all this residue now that's been returned, left on the soil. You're not only protecting the soil, but that material starts to be decomposed by the microorganisms in the soil. And it really adds to the carbon, the soil organic carbon, and provides all these benefits we've talked about, like building drought resilience, increasing infiltration. And this is not just something that's like academic, but the academics, the research has shown that this is very true. It really happens. Here, just an example of 6 states: Alabama, Iowa, Illinois, Indiana, Kentucky, and Nebraska. Just looking at the organic carbon in the soil in the conventional tillage system compared to the no-till system in each of these, just going on down the line, 60 to 73, 45.9 to 52.8. So you can see that research has shown for years now that when we convert from a conventional system to no-tillage system, that's an important way of being able to increase the carbons in our soil. And this is, this is not new. I think what is new, again, is to start to really think of yourself as a carbon manager so you can derive more and more of those benefits of having carbon stored in your soil. Cover crops, of course, is another opportunity for bringing in carbon to your system, to your soil. Is your ground going to lay bare during the winter and with no additional carbon inputs? Or now are you going to plant and grow a cover crop during that fall, winter, and spring? Are you going to wait late into the fall so that the cover crop doesn't have much chance to grow very much? And are you going to terminate it early in the spring so you don't have a lot of plant material that's grown? Or are you going to be able to plant that cover crop earlier in the fall. So now you can get some good growth. And so it can protect your soil in the winter. And so it can also grow in the spring. And so now when you get to a point where you're ready to plant your next crop, how are you going to do it? You can plant right into many of these cover crops, and what it can also give you is a mulch, and so to help hold more moisture and keep the ground cooler. There's a lot of benefits to it, but then it also, of course, decomposes and becomes part of that soil organic carbon, just as we talked about before. Then, of course, another management choice is your rotations. I know your markets, really drive a lot of that. But to the extent you have those choices, that if you can look at, particular crops and rotations and cover crops to go in between those main crops, then you can really step it up as an effective carbon manager in these systems. Of course, those of you that have the opportunity for integrating livestock, this is also a wonderful way of bringing in carbon to your soil, not just from like the forages and stuff that you can bring when you integrate, livestock with your cropping system, but also, of course, from the manure that they add to it. So this is a $64 million question that everyone wants to know is how long does it take to build a soil organic carbon? And you're probably not going to like my answer, but because the answer is, well, it all depends. It all depends on so many of those things that we just got through talking about here. It really depends so much on the management choices that you make. If you focus on being a real effective carbon manager and start looking at the type of biomass, the amount of organic matter material that you're adding to your soil, how you're managing that, then you can significantly increase the carbon in your soil, and you'll do it quicker than other people that say leave the ground bare or that till. But if you'll be convinced that you're going to no-till, you'll be really committed to no-tillage, you will definitely be able to do it. Usually it takes about 3 to sometimes 5 years before you have a measurable change in your carbon in your soil. Now I say measurable change because there's a lot of kind of a background variability when we try to measure it. And so it doesn't mean, though, that you're not having a benefit that first year or second year. It just might take year 3 to 5 before you have that measurable change, before you can, really kind of separate it from that background noise or that background variability. It also depends on climate, how cold it is, how, what your climate is in terms of how cool or warm it is, because that affects things like decomposition rate. Different soils also influence it. If your soil is sandy as heck, then you'll be in for a greater challenge. You can do it. It'll be in for a greater challenge. If really having a little clay in the soil really kind of helps form these what we call in the science world clay organic matter complexes. And so a little clay can also help you with storing more carbon in your soils. And then it also really kind of comes down to outlook, to individual perspective. We're all human. And some of you may have heard the old adage that if you think you can, you can. But if you think you can't, you're right. And so much of it is perspective. There are those that throughout life, whether it's carbon and farming or anything else, if someone thinks, well, no, I can't do that, well, then they're right. They're not going to be able to. But if someone sees the benefits and is committed to making it work, then they sure as heck can. And so that's also true with carbon management. So, in just kind of a quick summary, we talked about what is soil organic carbon, and it's just, it's nothing complicated, really. It's the carbon in soil organic matter, what imparts that dark color, to your soil. How does it benefit farming? We talked about it increases drought resilience through things like improving water holding capacity, increasing infiltration. We saw that with side-by-side pictures of one field versus another where the water was ponded on one side. but not on the other. We talked about how there's nutrients in organic matter and it's tied to that carbon. When the microbes feed on that carbon, they do that for their source of energy. Then what's released are things like nitrogen and phosphorus. And so that can really enhance the nutrient availability for your plants. We talked about how it could increase profitability, not just in the dry years, but year round. Our records are showing it's allowing folks to reduce some of their inputs and their input costs just with fuel when they convert to no tillage, but also some of them are able to back off on some of their nutrient management applications. But then also for those people that are participating in environmental markets, that can really be another good source of revenue for them for increasing profitability. It reduces density of the soil, allowing the roots to travel through the soil easier and take up those nutrients and take up that water. We talked about how can you increase it. It's really all about management. When you're looking at that balance of where your inputs of carbon are greater than your losses or your removal of carbon. And so it's just, it's so much of it is thinking ahead about what crops can I grow? What cover crops can I grow? How am I going to manage that carbon, that precious carbon that's remaining when I harvest here? And how can I optimize the use of that to build up the storage of that carbon in the soil? How long does it take? Well, we talked about that. It's based on your management choices, quite frankly. And so that's really kind of where the crux of the issue is really becoming a carbon manager in addition to your farming responsibilities. This is kind of an additional responsibility is to look at farming in this way also, as that you're not just managing livestock or crops, but you're also managing carbon. So I wanted to point you to a few pieces of information. I think the reality is so many of these decisions that are making these systems work for you kind of really depends on a lot of local expertise, because we have local people there that know, like, for example, what are the best cover crops to use here? When should they be planted by? When should they be terminated by? Those types of, things are very local decisions, because essentially all biology is local. And so I really like to point people towards their local cooperative extension offices, some of their local folks with the conservation districts and NRCS, the USDA SARE, the Sustainable Agriculture Research and Education programs. They've got a great website with some resources. And I know many of you work with local retailers and advisors. So I would encourage you to find some. Those are the ones that you're working with that are also of this mindset. And that are interested in helping you increase carbon in your soils. And of course, the Soil Health Institute is always ready to help out in any way we can. We do have a number of training videos and other resources on our website. I encourage you to check those out. So I hope this has been useful to you. And I also, again, I encourage you to visit us at the Soil Health Institute website, maybe sign up for anything that you would like in terms of our newsletters, and so any materials like those or our annual meetings, we would love to have you. So good luck, and good luck at farming. Thanks for everything you do as our nation's farmer.